Good morning everyone, I'm Gokul. Today we are going to present a project on measuring light intensity using ESP32 and LDR sensor with data stored in InfluxDB, transmitted via MQTT and visualized using Grafana. The main goal of this project was to monitor the intensity of light in real time using affordable components and open source tools. This kind of system can be useful in smart lighting, agriculture, home automation, or industrial monitoring. So, the hardware we used and the components in the hardware we used are ESP32 microcontroller. The reason we used this microcontroller is because it's low cost, obviously, and Wi-Fi enabled and very efficient for IoT projects. And LDR sensor, this is the LDR sensor and this is the ESP32 microcontroller. So we are now in the LDR sensor. This is used to measure light intensity. Some basic resistor wiring for the circuit to connect the two devices. So we're gonna discuss how this system works. So the LDR sensor detects the light and it sends the signal to the ESP32. The ESP32 reads the signal and convert them into digital light intensity values using ADC, which is the analog digital converter. These values are then published using the MQTT protocol to a broker. Finally, we use Grafana to visualize the data in real time.
We wrote the code in Arduino IDE. The ESP32 reads analog input from the LDR and connects to Wi-Fi. Then it continuously sends data to the MQTT broker. We use a lightweight MQTT library for communication. A Python script for telegraph can be used to subscribe the MQTT topic and write the incoming data to the InfluxDB. So this is an Arduino IDE and here we wrote the code and this is the data we are collecting from the sensor. And so this is our InfluxDB. We chose InfluxDB because it is optimized for time series data. Each light reading is stored along with a timestamp so we can track the changes over time. And finally, we collect the data in InfluxDB and then we connect InfluxDB to the database Grafana, because Grafana is one of the best tools available for data visualization. So that's why we use Grafana, and it is also open source for everyone. And to make the data more meaningful, we use Grafana. Grafana also allows us to create real-time dashboards where we can see graphs of light intensity, set thresholds, and even get alerts if needed to. So this is a line plot. And these are the three graphs we got. And the first one is the gauge graph. So the red value 6000, this shows the maximum light intensity value recorded during the selected time. It indicates a sudden peak or exposure to a very bright light source. And the value 61, this shows the most recent or current light intensity reading at the moment the dashboard was refreshed. So the red curve underneath the number represents how the value increased over time. Next, moving to the histogram. So the histogram chart displays the distribution of light readings across different intensity ranges. On the x-axis, the light intensity values are from 0 to 500, and on the y-axis, the number of readings fall to each range, for example, frequency. Most readings are concentrated between 500 to 2000, meaning this was the most common light range during the time window. And moving to the line graph, this is a time series line plotting, shows how the light intensity changed over time. So as you can see, the areas of stability and fluctuation between, there are small drops and rises, possibly due to moving shadows or changes in light exposure. So this is our project. So we used LDR sensor along with ESP32 to get the light intensity data, and then we collected the data into the InfluxDB, and then we connected InfluxDB to Grafana for data visualization. Thank you.